Let's take our next question, that is question number 3 of section 3. This question belongs to chapter thermodynamics. As per the question, answer the following by appropriately matching the lists based on the information given in the paragraph. In a thermodynamic process, on an ideal monoatomic gas, the infinitesimal heat absorbed by the gas is given by T delta X, where T is the temperature of the system and delta X is the infinitesimal change in a thermodynamic quantity X of the system. For a mole of monoatomic ideal gas of given this expression, that is X is equals to 3 by 2 R natural log of T by TA, where T is constant, plus R natural log of V by VA, where V is a constant, VA is a constant and R is the gas constant. We have to enlist that list 1 below gives the some quantities involved in a process and list 2 gives some possible values of these quantities. Let's see what are those. So as you can see here, this is list 1 and this is the list 2. Let's see the question first. So as for the question, if the process carried out on 1 mole of that monoatomic ideal gas is shown in figure, this is the PV diagram, where a special instruction is given to us as P naught V naught is equals to 1 by 3 R T naught. We have to find the correct match. So very first thing is, if you see the first option, work done by the system from 1 to 2 to 3. So let's see. So if you see from 1 to 2, let's start with the solution. So work done from 1 to 2 and 2 to 3. Simple. From 1 to 2 definitely there will be some work, but 2 to 3 work done would be 0, right? So whatever work done here is this, and this will be easily given by P naught V naught, that is the area, and this is equals to 1 by 3 RT naught. So this is the first answer to the question. Now this was the first option. Now if you look at the second one, that is change in the internal energy from 1 to 3. So change in internal energy is simply delta U 1 to 2 to 3. It is NCV delta T that will give you the change in internal energy. So what is the temperature at here? So this T1 would be equal to P naught V naught by R. Here the temperature would be equal to 2 P naught V naught by R, and here this is T2, and here the temperature T3 would be equals to 3 P naught V naught by R, right? So what is the delta T from here to here? Since the internal energy change, it's finally we can say that T3 minus T1 into NCV, and that will give us only 3 P naught V naught. And this 3 P naught V naught, if I replace this by 1 by 3 RT naught as per the question, it is left with only RT naught. So I have delta U with me. Now if somebody asks you what is the heat given from 1 to 3, it's simply the summation of these two, which would be equal to 4 by 3 RT naught. Let's see which is the best suited option among these. So for the first case, what we had is, that is the work done by the system 1 to 3. So you can see that it is matching with Q. Right? Now second, change in internal energy of the gas, it is matching with R. And what is the third one we have? So for the third one, heat absorbed is, yes, we find this is 4 by 3 RT naught. So out of this 4, I have already found 3, that 1 is mapping with Q, 2 is mapping with R, and 3 is mapping with S. So QRS is our sequential answer. So these 3 are sufficient to find the answer here. As you can see, for 1 it is Q, all the 3, this cannot be there. Then for 2 it is R, so this cannot be the option. Now among these 2 there is a fight. For 3 it is S, so yes, this is the right answer, this cannot be. So the correct answer to this question would be option 1. I hope you have understood the question. Now let's move on to the next question. Now the question you see is again the continuation of the previous question. This is the same data. Let's see what is the need of the question. So this is the list, and as per you see, the question is, if the process of 1 mole of monoatomic ideal gas is as shown in TV diagram. So initially it was PV diagram, now it is temperature and volume diagram, with the instruction of same P naught V naught is equals to 1 upon 3 RT naught. The correct match is, so let's see what is the first requirement. The first requirement is the work done by the system in process 1, 2, 2 and 3. So let's see, as per the graph here, you can see here that in this case the work done would be 0 because there is no change of volume, and certainly there will be some work done here, and this is isothermal work done. Why isothermal? Because temperature is constant. So if you want to find the work done from 1 to 2 to 3, it will be only the work done of isothermal process. What is the formula here? So you can write RT log of natural log of V final minus V initial, right? When you put down the values, it is RT naught by 3, because the temperature here is T naught by 3, into log base E2. So this is the work done 1 to 2 to 3, right? We have this one. Now the next demand is, so next demand would be the change in internal energy in the same process of 1:2:3. So when you see here as the graph, change in internal energy from here to here, you can finally find this is the temperature T1 which is given to us, this is T3 given to us, and this is the monoatomic gas. So CV would be 3R by 2. What is the number of moles? That is N equals to 1. So directly delta U can be found. So delta U can be N CV delta T. So this is 1 into 3R by 2 into T3 minus T1. So solving this, you will get R T naught. This is delta U for us. Now the third part, that is heat absorbed by the system in this process of 1:2:3. So it's simply the summation of work done and delta U. So Q would be equal to R T naught by 3 natural log of 2 plus R T naught. We have this answer. And let's see what is the last demand. So last demand would be heat absorbed by the system from process 1 to 2. So as you can see here, from process 1 to 2, the temperature is constant. So here delta U would be 0. So what is the heat absorbed? This would be equal to the W of isothermal process. So the last option, that is Q from 1 to 2, will be simply W isothermal process, that is R T naught by 3 natural log of 2. Let's see which is the best suited option. So for first option, that is work done, we have this, right? Now for change in internal energy, we had RT naught. Then for the process of heat absorbed, we had this, that is 1 upon R3 naught 3 plus natural log of this one. Then the fourth one, that is the heat absorbed by the process 1, 2. So again we have to move to this process of P here, right? Because this was the work done of isothermal process. So from the 4 matching, we can find that option 2 is the correct answer to this question. I hope the solutions were useful to you. Friends, we have come to the end of this paper solution. I hope the solutions were useful, and all the best for your results.